I will be answering exercise 39 for my Viva, and that question is, show that the symmetries of a hexagon are isomorphic to a subgroup of S6. So the first thing I'm going to want to do is just work out the symmetry group of the hexagon. Now, there will be 6 reflections and 6 rotations. And I'll just label the lines up and the angles of rotation. So E, the identity, and then A squared, where A will be 2 pi over 3, A squared will be 4 pi over 3, etc. So there are 12 elements in the symmetry group of a hexagon. Now, the second half of the question references S6, and I know that S6 is the group of all permutations from this. Now, if I was to label each vertex of this hexagon, like so, I will be able to link the symmetries here that I found to S6 by writing what happens to each vertex in cycle structure form, which is what I've done here. Now, I'll just go through phi of W. So, start with 1, and W is a line of reflection here. So 1 is going to be reflected to 3, 2 will be fixed, 4 will be reflected to 6, and 5 will be fixed, like so. Now, in order to show the isomorphism, phi must be a bijection and homomorphic. By definition, we know that a permutation is a bijection from itself to itself. So this shows us that phi must also be a bijection. Otherwise, the two groups, if we say this is G and this will be H, the two groups G and H would not be isomorphic otherwise. We can further prove this by seeing that all elements in G correspond to an element in S6, which is what we've just done here. So A3 will correspond to 1, 4, 2, 5, 3, 6, etc. So we know that any two or 3 or any element in this symmetry group is going to do different things to the labels that we have labelled here, hence 1 to 1. Furthermore, all our cycles are disjoint because none of them have the same elements in. If we wanted to take a look at A circle A4, we can deduce from this that A circle A4 is going to be A5, which we can see if we were to use these drawings here. Now A circle A4, we would do A4 first, A4 then A, so they would all rotate, and then the final thing would be 3, 2, 6, this one here. So, once we have figured that out, if we applied phi to these, like so, we would expect to get phi of this. So we would check that using the corresponding cycle structures that we've worked out previously. So it would be and obviously we start here because that's the form in which we do that. And our final, if we would start with 1, map to 5, mod 1 maps to 5, and 5 maps to 6. And then if carefully repeat that for all of them. Then our final answer will be 165432, which is phi of A5, as we would expect. Therefore, using the fact that our cycle structures are in disjoint form, and we have now seen, using the list we worked out here, that each element in the symmetry group of the hexagon corresponds to a cycle structure in S6, we are able to say that we have shown that the two groups are isomorphic.